Hi guys, Mark here, and here we are on day 20 of the Advent of Code Challenge. And of course this morning, the first thing I looked at after yesterday's difficult problem was the leaderboard to see how quickly people were solving it. And as we can see, this is one that some people managed to solve quite quickly, and yet when we scroll down we do realise that this is still quite difficult compared with previous days. Normally this leaderboard will fill up in 20 minutes. So there's a potentially taxing challenge ahead of us. So let's look at the problem. And the problem itself really is quite simple. You've got elves that are delivering presents to houses in a street, and elf number 1 delivers 10 presents to every house. Elf number 2 delivers 10 presents to houses 2, 4, 6, 8, and elf number 3 to 3, 6, 9, 12, and so on. So you can easily work out with a bit of maths how many presents are delivered to each house. And all you need to do is find which is the first house that gets at least, and where was my number, 36 million presents. Okay, so as usual I attempted this in C# and F#, so let's have a look at some code. So here we are in C#. And the way I initially attempted to solve this problem was to create an array of houses and add up how many presents were at each house. But I backed off that, and as we'll see later, I probably shouldn't have done. And I decided I'd make a little function called presents for house. So presents for any house would be a range from 1 to the house number, and then if an elf delivers to that house, so if the house number modulo the elf number is 0, then we add that up and multiply by 10 because each elf delivers 10 presents. And so then all we would need to do is go through each house number and ignore this where line just for a moment and select the house number and the number of presents for that house and find the first thing in that sequence where there are more than 36 million presents. Now, I ran that and it was very obvious that it was running really slowly. And so I needed to find a way to speed this thing up. And I decided, do I really need to search every single house? It's more likely that the houses with lots of factors are going to be the ones with lots of presents. And so I said, I'll only test a house if it is divided by 3, 2, 3, 5, 7 and 11. And that actually works quite nicely. It got me to my answer pretty quickly. But then we got to part B of the problem. And in part B, the elves are now delivering 11 presents to each house, which is not a particular problem, but each elf will stop after delivering presents to 50 houses. So the presents for house is very simple. It's almost exactly the same. We just multiply by 11 and we only deliver if the house number divided by the elf number is less than 50. However, it's less clear which numbers we can skip. And so I ended up kind of doing a little bit of experimentation, just looking at small batches of number of presents for 10 houses around different high numbers to try and get an idea of what sort of numbers were getting the highest values. And in the end I settled on deciding that the house number would probably be divisible a few times by 2 and 3. And that speeded this up just enough, and also only started searching at house number 700,000, again to speed things up a bit. And that got me to my right answer, but it did take about a minute and a half to run, so not particularly optimal. So in one sense we could say, mission accomplished, we've got our 2 gold stars, we've solved the problem. And yet this does feel a little bit ugly. Were there any other ways I could have optimized it? And it turns out that there were 2 ways of optimizing it. One I'm going to show you in F#, and the other I'll show you in C#. So let's go over to F#. And the trick that we can use in F# is that the number of presents for a house, for part A, is basically the sum of all the factors of that house, or all the numbers that evenly divide into that house, because that's all the elves that visit multiplied by 10. And for part B, it's only a little bit more complicated. Again, it's all the factors, but we again have to check that the house number divided by that factor is less than 50. And really, the factors are the elves that we'll visit. So how do we calculate the factors? Well, someone on the subreddit, Jeff, came up with a nice little factor function. I've changed it very slightly to meet my needs, but basically we're looking in the range 1 to the square root of the number and seeing if it evenly divides. And if it does, we return potentially 2 numbers. And the reason potentially 2 is that if we had a square root, we wouldn't want to return the same number twice. Otherwise, we'd have the same elf visiting the house twice. And it should be immediately obvious why this is going to be so much quicker. If we're testing how many presents get delivered to house 1,000,000, well, in my C# algorithm, we need to count to 1,000,000 and check which elves will visit. Whereas in this algorithm, we only have to count to the square root of 1,000,000, 1,000, and check which elves will visit. So this is going to be several orders of magnitude faster. And once we've got our presents for house A and house B, then I've got a little search function that goes through the sequence of numbers we're testing, works out how many presents are delivered to that house, and finds the first one where the number of presents is greater than the target we're aiming for, which is 36 million. Now, what's this test sequence about? Well, actually, I kept my optimization that I had created in C# and created a little sequence that started from 700,000 and only included house numbers that were divisible by these factors that I'd worked out. So that provided a second level of speed up. And so this, when I ran it, managed to speed up my algorithm for part B from 18 minutes 30 seconds to under a second. So an amazing speed up there. But there is one last solution I want to talk about, and that was the idea that I said I originally had when I started tackling this problem. Why not create an array of all the houses and just work out how many presents are delivered to those houses? And as I said, it was a shame that I backed off this idea because it works really well. If we're trying to find the house that gets 36 million presents, then we only need to test at most 3.6 million houses. And what we do is we go for each elf, let's work out which houses they visit, and for that house add the elf number times 10 presents to it. And then just go through all of the houses to see the first one that has more presents than the target. And for part B, it's the same. For each elf, work out which houses that elf visits, and they stop after 50, and give that house 11 presents. And so when we run this, we see in just a couple of seconds, it has solved the entire problem for us, and without any kind of special hacking around to reduce the number of houses we're testing. And so it's amazing just how by approaching a problem in a slightly different way, you can radically change the speed and performance of that problem. This is the algorithm that the person who got first on the leaderboard used, and they wrote about it on the subreddit if you want to find out a bit more. But I thought this was a great problem because it could be solvable by brute force if you had a lot of time on your hands, but if you're a little bit clever about the algorithm, you can speed it up dramatically. Anyway, thanks again for watching, and hopefully I'll see you tomorrow.